Hello, automating success followers. Today I got Vinod Kettay here with, he's the CEO of Vectra Automation. And I'm super excited to interview him because then he's told me to call you Vin for sure. You said, Vinod?
Yes, you can
Yeah.
call me Ben.
So I'm really excited to talk to Vin because he's passionate about automation, but he's also I love cars, and he started at General Motors, actually working on Grand Prix car line. So and honestly, my mom had a Grand Prix. A lot of my friends had that vehicle, so it's kind of cool for me to talk to someone like Vin. So I want to welcome everyone to Automating Success, and I also want to welcome Vin, and I'm going to allow him to introduce himself because I'm sure he'll do a much better job of it than I would.
Thank you, Joe. I'm Vinod Kettay. I'm the founder and CEO of Vectra Automation, and I'm really glad to be chatting with Joe here. The podcast seems very interesting, and happy to take questions and go from there.
Sounds great. So, kind of let's just get started with, what got you into the space? You're engineer and manufacturing. Looks like from my research, you worked at General Motors. Let's start there. Sounds a good place to start.
Great. So I started my career with General Motors in one of their automotive assembly plants. This was way back in 1989 in New York. And I was responsible for manufacturing and product integration, which also meant that I interfaced significantly with the manufacturing teams and the engineering teams, and also was responsible for commissioning automation that's being used to build cars in a more automated manner. So that's where I got my start. And then in the second half of my career at GM, I was the program manager for the Pontiac Grand Prix. So I had dual responsibility. One was managing the operations for the model, which had already been brought into production. And simultaneously, I led the launch of the next generation Grand Prix, took it all the way from concept initiation to product launch, and then I left GM. So my whole career until that point had been in automotive. As a mechanical engineer by background, it was my dream to go work for a car company, and that came true. And my bachelor's degree is in mechanical engineering, and my master's degree is in industrial engineering. So that's how I got my start. Once I left GM, I did some consulting for a bit independently, and then I started Vectra Corp in its original avatar. At that time, we were a design service company like hundreds of similar companies in the world. And when we got started in 2005, our sole value proposition was lower cost engineering services. I set up our team in India to support our clients in the US, and our clients would create 3D CAD models of the tooling and other systems that they were designing. And but to actually manufacture those systems, 3D CAD models are not adequate. You actually need two-dimensional engineering drawings, which have a lot of information on them to enable somebody to manufacture those systems. Number one, you need datums, which indicate where measurements will be made for the various manufacturing processes that would be physically used to create those parts. And then you have various features and engineering drawings that have to be measured from the datums, depending on which manufacturing process would be used. So that's where we got started. And in a few months, it became painfully obvious that this was a critical bottleneck for any manufacturing company. And we were spending more than 25% of our manpower on correcting errors in the 3D CAD models and also in engineering drawings. All these were errors that really shouldn't have been there. That essentially gave rise to the thought that this process could really benefit from automating it, just like I automated so many of the manual processes and the assembly plants that I had worked in for General Motors. So this was similar, but this would essentially be automation that ran on a software platform, not automating mechanical manual work, but it was automating mechanical design. And when you look at, consider the aspect of creating engineering drawings, it's actually the very last step in the engineering workflow. And it's the essential bridge between product engineering and manufacturing. So when engineers complete the design of the systems, you still need 2D engineering drawings to be created so that manufacturing take over and actually manufacture those parts and systems.
So, one of the things I find with anybody that kind of changes path, right? There's usually a reason for it. So the first thing I want to circle back, and then we're going to come back to break down some of the things you just said. So you check the box from what I'm assuming. You work for a major car manufacturer. You made the Grand Prix, right? Now, first, I just want to say I want to ask you a question. Every time if you saw a Grand Prix driving down the road, how proud were you? I mean, as someone that's never designed a vehicle before, there has to be a certain level of pride. And I mean, how cool is it, right? Or how did that feel for you?
That absolutely fantastic, especially when the it was the I think it was a Grand Prix model that did the best in the market probably since the 60s. So and it had a really cool look to it with a lot of engine power and tremendous handling capabilities for a car that's essentially a sedan. So it was really cool working on that. And of course, we had a lot of challenges in terms of financial considerations and the legacy costs at General Motors. So we went through a lot of challenges in launching that car. It's never easy launching a car. There's just so many teams involved, so many things that have to come together in a certain way, and then you manage all these issues. So it's really the culmination of hundreds of people working together as a team and bringing this concept, which is just a sketchy idea that the brand team comes up with. And there's so much discussion with the studio, the people who do the design of the car, the styling of the car, which makes it hopefully very attractive to the target buyer. And there's so much, it's so much beyond just engineering. There's so much of art that goes into creating a car that people will actually fall in love with and just want to go buy one.
Yeah. Well, and I mean, I don't know if this will be inspirational for you, but my mom traded in her 1990 Lincoln Town Car for a Grand Prix.
Oh,
Black
wow.
Grand Prix with supercharger, I mean, it was, so, I mean, even talking about, how you guys somehow were netting him, because that was a popular car, back then. I don't know. I mean, when I saw my mom go from a town car to that, but it was a pretty awesome car. Peppy had the little supercharger line to it, it was pretty awesome. So, okay. So you talked about the hours and the time that it took to put in, but after you did that, I'm trying to figure out what took you from making that car and not just staying in that and then making the next one. I mean, was there something in that process that made you see a need to start Vectra Corp, or was it just a passion? You just wanted to do something on your own?
It's the latter. I really had this itch. My dad was an entrepreneur, and I always had this itch. But just coming out of college with my master's degree, I really wanted to work for a big company and be part of a big team doing something exciting, and nothing excited me more than working on cars. So I was really fortunate to get that job at GM. And so but at some point, it became obvious to me internally that I just wanted to go get out there and track my own future, not be dependent on this big company. And that's when I started Vectra Corp. And the reason I chose this aspect of creating engineering drawings from 3D CAD models using engineers in India, that's the time that business process outsourcing was really taking off. And a lot of companies in the US and Europe were leveraging companies in India to execute these processes for them at lower cost. So that's why we went down that path. Um, but as we went down the path, I immediately realized that for my team members who were working on this, this wasn't very exciting. It is very mind-numbingly boring work for an engineer to do day in and day out. There's not a lot of creativity in creating engineering drawings themselves. The creativity is in creating the 3D CAD models, which capture the essence of the system and the functional requirements of the system. That is what is truly challenging, what is truly exciting for an engineer to work on. To do this aspect of creating engineering drawings, yes, it's error prone because humans make these mistakes in selecting the datums and providing the right views which have to be shown on the drawings. There's a lot of aspects to it. It is very technical stuff, but once you train an engineer to do it for a few months, he's done it, he's not really learning anything new from it. And the hard fact of business is people don't want to stay in this process for too long. They want to move up to 3D CAD modeling or something else more exciting where you're actually using your real engineering skills. And we had a lot of employee turnover for that reason. And this was endemic to the industry as a whole. Nobody really wants to do this. But you have hundreds and thousands of engineers employed across the globe, and a good number of them work in India, who are just doing engineering drawings for a living. And the fact of the matter is, they make a lot of mistakes as they create engineering drawings. And those errors had to be looked for and identified by checkers downstream. They're the quality control people. We call them checkers in the industry. And what happens is that the checker not only has to look for errors in the engineering drawings, he also has to look for errors in the 3D CAD models themselves, which our customers are responsible for. So the checker also is a scarce resource. It takes a certain mindset for a person. And to be a checker, you need a lot of years of experience because you're looking for errors that people can possibly make. And you need a certain mindset to be able to sit in front of a computer or printed sheets of paper looking for errors that somebody else made and marking them off, checking them off with red ink, sending them back to the design team to fix the 3D CAD errors and also fix the errors in the engineering drawings, and then wait for them to send it back to the checker, where the checker has to do a back check to ensure that they fixed everything he had marked up. And then it's ready to be released for manufacturing. However, the checkers themselves, as conscientious as they may be, they're typically working 12 hours a day, 7 days a week sometimes, when there's a huge project going on. Say if you're launching a new Grand Prix or a new Mustang, there's a lot of engineering work, and there just isn't enough time to do this. And this whole process of going from 3D CAD models to engineering drawings can take 3 weeks to 8 weeks, depending on the complexity of the system and the quantum of workload of engineering that's going through the system at that point in time. So the checkers miss a few things. And when those errors end up in manufacturing, they have a more dramatic effect on the total system. They find that, say, 2 parts don't fit together when they're trying to assemble them because one of those holes was improperly located in the drawing or the 3D CAD model. And therefore, they find they can't make these 2 parts together. They have to stop the process. They have to call the design office to fix the drawings and send them updated drawings. And then they have to rework the parts, and they end up paying their manufacturing team overtime to get caught up. And then they have to basically get caught up on the shipping deadline, which is not changing. So there's just so much chaos.
Yeah. So, I mean, first of all, in what you described to me, I can't imagine being a checker, but I feel like I'd go blind or just in boredom, and also I feel like you'd probably get so upset if someone is making the same mistake constantly and you're looking at it and you're pushing it back up the chain. So which part, so now help me with, what Vectra is automating then. So I'm assuming I'm starting to assume that you were automating the 2D, the component that's boring to people. But now I'm wondering, are you also automating the checking portion? Because I feel like you're probably doing this with some sort of AI. I mean, so explain how you're basically taking the mundane, boring work and you're automating it. Am I following you? That's what's happening?
That's correct. We initially set out to automate the drawing generation process, the boring part. But when we first launched our product with a customer and went live, we realized that there were the errors in the 3D CAD models that we were familiar with were actually impacting the output of our drawing generation software, which we call Auto 2D, because the designers were creating errors. And unfortunately for us, the quality of the 3D CAD models were not being checked until after the drawings were being generated by our software. And because they were incorrect inputs in the 3D CAD model, which is essentially the input for our software, we had to rework the outputs coming out of our software, and we realized in a couple of weeks that this was not a sustainable process. The obvious solution is to go to our customer and say, hey, we need your designers to do a better job of creating the 3D CAD models. But that's like pushing on a rope, because here you have these engineers, these creative guys, they're doing their best to get all this work out the door as fast as they can with the limited resources they have. And they're still human. They are going to make mistakes, going to miss something. That's when we had a serious conversation with our customer and said, okay, we want to fix this. We want to automate the 3D model checks that you currently do, but we want them to be done before the drawing generation process so that the drawing generator gets clean 3D CAD models as its inputs. And we told our customers, we will build these QC modules, which your designer can use after he completes the 3D modeling process. He can run it on his own system, and those QC modules will identify and report all possible errors in the 3D CAD models. And once we instituted that, and the typical kinds of errors that manufacturers of assembly tooling run into are misalignment between holes and shafts, holes and slots, and then you have a lot of interferences between components which shouldn't be there. Sometimes you have small gaps between components that shouldn't be there. So our QC modules were developed to identify those specific types of errors in the CAD models and provide a report. But the designer himself, once the report has been produced, he would have to click on the error report that would take him into the CAD model, and he would have to fix the errors still manually. But at least now you're placing the burden on the engineer himself so that he knows that he's making these mistakes and he knows not to repeat this, because the more mistakes our QC modules identify, the longer it's going to take him to fix those. So he's more conscious about the errors he's been creating, as opposed to just letting somebody downstream like a checker find those errors and report them back. And in fact, when in the old process, when the checkers would identify the errors in the 3D CAD models, a lot of times those, what we call checker markups, were sent back to our team in India to fix even the errors in the 3D CAD model, which technically wasn't our responsibility, but in the interest of being good partners with our clients, we would do that. And in some cases, our customer would send those 3D CAD error reports back to a junior person on their staff to fix it. So the person who actually made the mistake may not even be aware that he made those mistakes. And we took that whole do loop out by automating the QC modules and giving the engineer the ability to check his work for himself.
How does one go about automating? So like let's start to break that down, because so I think you've broken down, like, I mean, literally how, I mean, when I'm listening, I'm hearing how much work and how much repetitive work and checking and making sure like layers are not missed, and then being able as an engineer to try to visually put this model together and know if there's going to be, gaps or breaks or however you said. But, now you identified the problem. How do you actually automate that problem? I'm very interested.
That is the hard part. And that's what our team is very specialized in. So the aspect of checking for gaps and interferences and misalignment between holes seems pretty mundane. If you gave a human being enough time, they could find those things on their own. The whole issue was there wasn't enough time, and there was a lot of stuff being pushed down the chute at the same time. So that was the issue. So we've used a lot of very sophisticated algorithms that we developed in-house, and there were some algorithms which existed elsewhere, used for completely different purposes. We repurposed those algorithms to automate all the checks we are doing in the 3D CAD models. Now,
sorry to interrupt, but so did you do all this stuff in-house with your people in India, or did you like partner with some people that specialize? Because you said you reuse some algorithms and stuff like that. So it's like, I'm always interested, I'm intrigued to know if like, this is something you started from scratch, or if you realized there was a problem and said, okay, we kind of have this over here and we can adapt this. Like how did that work? Right?
It was really a combination of both. So as we tried to find specific solutions to the problems that we defined, sometimes we were lucky enough to realize, oh, okay, there's already code out there that we can repurpose for our particular situation. But in most cases, I would say 80 to 90% of the time, we had to create our own algorithms to find those, to tackle those problems. Now, once we did that for our first configuration, so first configuration being General Motors standards for body assembly tooling, once we did that, then we were able to leverage outside partners. These were consultants who could write programs for the NX-CAD platform, for the Kettay CAD platform. Once we had the initial algorithms developed, we were able to give bits and pieces of interfaces to our partners so they could write the code to tackle the same type of problem for other OEM standards like Daimler and what used to be Fiat Chrysler and Volvo and companies like that. So we were able to leverage a lot of development partners outside of the company without giving away our intellectual property.
And so who are your target customers at Vectra? Is it all automotive space, or what spaces are you guys operating in? Because it sounds like you're like I don't want to call it a subcontractor, but you're your own thing working for these corporations, right?
Yeah. So to be specific, we are a software as a service company. So our software is priced on a monthly subscription model, which is the amount of the monthly subscription is based on each customer's forecast of their manual engineering drawing workload for the next 12 months. And we also monitor the actual usage because, setting a subscription level based on a forecast is not always smart because they can overuse or they could underuse our software. So we make adjustments to the monthly subscription as we go along so that the head of engineering is never in a situation where he has to go explain to his CFO that he wrote this check over the months for Vectra and he didn't use all of that. So we make adjustments for the next contract period so that they recoup whatever they paid in the first period in the second period. So where we got started off was with the tooling integrators for the automotive industry. That's where we got started. Where we are focusing on going forward is on the really large companies. So the companies we've been working with have revenues in the range of $1 billion per year. We are now going after companies which have revenues typically more than $10 to $20 billion, going after companies in the automotive sector, all the automakers. They're large tier one suppliers, but we are not at all limited to the automotive sector. Any company that is in the business of manufacturing mechanical systems is going to benefit from Auto Duty. It could be a company that makes parts that go into cars, or the OEM that makes the entire car and assembles everything together. That could be in the aerospace or defense sector, as a company making wing systems or aircraft engines or seating systems for aircraft, the fuselage systems. It could be anything that's mechanical in nature. And the same thing applies to companies that produce oil and gas, refinery equipment, drilling equipment, shipbuilders, and going beyond what you typically consider as a mechanical system. Auto Duty has also been identified to fit into architectural design. And it's actually going to be easier than architectural design, because when you design a building, whether it's a stadium or a hospital or a school or a house, you don't design these complex parts that go into, say, a car or an airplane. These are typically straight and with some features in them. So, and architects also have this huge bottleneck. They like to focus on creating the 3D CAD model that is visually appealing to the customer or the consumer. But then you have this whole other team that comes in and puts in all the structural members, like the steel columns and beams and so on. And then they have to go dimension all of it, which is very time consuming. So that's where Auto Duty comes in and does all the dimensioning and sets up all the views, a plan view, a side view, a section view, wherever it's needed. Auto Duty automates all of that. And again, it has the same impact of reducing the lead time by several weeks.
Well, one of the things that you might find interesting is I actually, after I went to school for small circuitry, I actually was a union electrician for a while. So everything you're talking about with those buildings makes a lot of sense to me, because I can't tell you how many times I ran a pipe rack and it turns out there was mechanical ductwork that needed to go in that same elevation. And the amount of time and money that cost, and finger pointing on who's going to pay the back charge for the time it took to change all the pipe racks. So I totally see the value in what you're doing. And just for the people listening, I have to say, this is why I love doing this show, because, when people walk into a building, or like you said, a stadium, all anybody's ever looking at are the aesthetics, but they're never paying attention to what's behind the wall or what's in that ceiling. And there's a lot of time and effort that went into making all of that mechanical, like whether it's ductwork, electrical, support beams, fit in that space. So it sounds pretty cool that's, I get to talk to somebody that's figuring out how to make that happen more efficiently. So is that like kind of what you're trying to do at Vectra, like next? I mean, you basically said you were starting with $1 billion corporations. Now you're working with $10 billion corporations and higher. But now you're getting into those spaces. So, how, is that what you're doing to grow the platform Vectra? Because it sounds like what you have, you can stay really hyper focused in what you're doing with Vectra, but now you just have to increase how many different industries you can touch. Am I on what you're trying to do?
Exactly right. So we spent, even after we did our initial launch of Auto Duty, there were so many refinements we made, and we applied for a patent on our technology, and we defined the process. And because it's so there's so many human touch points. It took a while to figure things out. And now we are at a point where we can scale across industries, across engineering domains. So when I say engineering domain, I'm talking about the fact that we got started with body assembly tooling, and OEMs in the automotive space are asking us if we can do this for their structural components, their propulsion system components, where the plastic parts that go into the cars, the chassis components, including all the suspension components, the brake systems, and so on. And the answer is absolutely yes. And these different systems that I describe as subsystems have very different functions. The braking system has a very different function than, let's say, an axle that's transmitting torque to the wheels. So they have very different functions. But people ask me, okay, the functional characteristics of these systems are so vastly different. How can you claim to be able to generate engineering drawings automatically for so many different types of systems? The answer itself is actually quite simple. Our software is really not concerned with what the ultimate functional requirements of the system are. It really doesn't. All we care about is whether it's a part that's gone into an HVAC system or a braking system or a fuselage system. There are only, we don't care about the function of the parts. All we really care about is what are the manufacturing processes that will be physically used to create the features, the geometric features that are represented in the parts. And there are literally a handful, or maybe 10 or dozen manufacturing processes that are used to create any kind of mechanical part. You start with, say, a block of steel, and you're going to cut that to a certain profile. So that's a cutting operation. Our software doesn't care whether you cut that with a bandsaw or a circular saw or a water jet cutter or a laser jet cutter or even electrodischarge machining. We really don't care. If our software determines it was a cutting operation, it has to be dimensioned in a certain way. That's what we concern ourselves with. And it doesn't matter whether that part which was cut is going to be used in a brake system or an HVAC system. To us, it makes no difference. And then the other manufacturing processes that come to mind are obviously casting and forging. And then you have machining, and you can machine several types of features. Then you have drilling operations. Then you have bending. You have assembling the various parts together into assembly. And I think I'd mentioned welding. So literally about 10 different manufacturing processes. That's what we are built a map between geometric features that we encounter in a CAD model and the manufacturing process that will be used to create those features, and then another map to how those features need to be dimensioned. And a big part of that is done with machine learning. And that's what is going to enable us to go from one customer to the other, in one domain to another, with no concern for whether it's heavy industry or automotive or defense and aerospace. It really doesn't matter to us.
So is there any AI component to what you guys have, or is it just all basic inputs, outputs? I mean, right? That says, because I'm just wondering, the more you do of this, if it's your team learning and then tweaking kind of the model, or if it kind of teaches itself.
So,
and I don't know if you can expand on that with the patents and stuff
I
like that.
can. Yeah, to an extent, I can expand on that. So keep in mind that AI is really useful when you don't need a precise answer, where there's only one answer that's possible. So if you're trying to predict the weather, and if you predict using AI that tomorrow's high temp is going to be 69 and actually ends up being 70.5,
you can correct it.
It's not a big deal. It's okay.
Yes.
Look, we're not going to get upset with you, but for drawing generation, there's only one correct answer. So AI as a whole is not a good application, but machine learning is a subset of AI, which can produce a lot more precise answers. And even with machine learning, there can be a certain percentage of errors, which is far fewer than the human errors that we get. But with continuing to refine our machine learning models, we can even fine tune those errors out. And another key point in our process is after our software generates the drawings, Vectra still has a manual QC team that quickly looks through the drawings. They don't find a lot of errors, but when they do, they fix those drawings manually and give them to the customer so the customer gets drawings back in a day or two at the most, because our software takes about 8 hours to generate overnight, and then our QC team takes over. So ever since we instituted this process, our customers who used to send us checker markups on a daily basis when we were a design service company, they don't send us checker markups anymore. Not to imply
Oh,
that our drawings are 100% perfect at their end, but it's a realization of our customers that these whatever errors that remain in the drawings are so minuscule, it's faster for them to just fix it and be done with it, as opposed to send it back to us and have us fix it, which is going to take another day or so.
well, congratulations on that. That seems like quite a transition and a milestone, I suppose, on what you guys do. So how many people are on your team at Vectra then?
We're around 60. I know what, 55 in India, about 5 in the US.
Okay,
And we're going to be
and
growing the team pretty radically later this year.
where are you taking the call from right now?
Raleigh, North Carolina.
Oh, good, yeah, awesome. So what countries do you guys currently operate in then? I mean, is it all over the world, or like, is it mainly North America? Where do you guys?
Right now, we are just in North America, supporting customers in North America. But later this year, we are going to expand out of the automotive space into, we're already having conversations and we're doing one configuration for a company in the defense sector. And we expect to have 2 companies on board in the defense sector later this year. And we are initially going to focus more on the US and European markets where the labor shortage is more acute and the costs of generating drawings are much higher. Eventually, we will get into Asia Pacific as well.
Awesome, awesome. So unless there's anything else you want to cover with Vectra, because I think I have a very good understanding, which means the audience does. I'd like to take some time to kind of find out a little bit of your personal background besides the engineer and problem solver in you. Is that okay?
Absolutely.
Awesome. Okay, so tell me about your background. Start with your family. I mean, take me back to the child that kind of things you used to do when you were a kid. Because I always like to kind of see, you said you kind of had the entrepreneurial bug, and I definitely had that same thing. So I just kind of want to see if there's any parallels in our childhood.
Sounds good. So I was born and grew up in the southern part of India, a very big city called Chennai, and it's now a major automotive hub in the last 20 years. And growing up there, I actually went to Catholic school, although our family is not Catholic. The, the Catholic priest ran the best school, at least what used to be the best school in Chennai back then, Don Bosco. So that's where I studied, and still very close to a lot of the kids I went to school with, and stayed in the same school from kindergarten till 12th grade. And my favorite things growing up was playing cricket. Cricket is not a game that's well recognized here, but it's a British game, and India being a British colony, it's become it's not officially the national sport, but definitely the most popular sport in India. So we kids used to go out and play cricket in our summer vacation. It would be 105 degrees Fahrenheit outside with 99 degrees relative humidity. Didn't phase us one bit. We would just go out and play, have a great time. And growing up, our my friends and I had a very deep exposure to Western culture. We grew up listening to rock music and like the Beatles and Pink Floyd, and these were our favorite rock bands. We really didn't identify that much with Indian art, which is, Hindustani music and Carnatic music. We didn't identify that much with that. So when I finished engineering college, it felt like a natural thing to want to come to America. And the propaganda of American movies, it's powerful. It really makes you want to come and live here. So that's what I did. And
So was it what was it everything you expected it to be as a child, wanting to come over?
I would say for quite a bit, and
Not
one thing
well,
that
because you said the propaganda, like the American movies and stuff. I wanted to see if it overpainted like the portrait of the United States, or if you think it was accurate.
so actually when I came here, I was really impressed because there was such a vast difference from where I came from, and I could just see that everybody had a car. That was so impressive to me. In India, you'd have to be at a certain bracket to have a car. It was impressive seeing that almost everybody had a car. That was impressive. But as I lived here, then the problems and the system became more evident to me. I became more conscious of the failings in American society, and I hope I can do a lot to fix some of those things as I, start to retire and have more time to take care of these things. There's just so much economic inequality in America, which I really think shouldn't be there. Maybe some people have called me a socialist for saying that, but I don't know. I feel this country sets the stage for everybody else. There's the beacon of democracy and freedom in the world. And I think there should be more equality here. And there's no reason why Americans should be starving. Why should kids in America go to school hungry? I think that's all just terrible.
I don't think that makes you a socialist. I think it makes you a humanitarian, and I think it makes you just a person that's passionate about a fellow human being. So I don't think it makes it. I don't think I would label it socialism. I think I would just say you have a large, kind heart. So that's the
And
way
I'm
I see it
happy to
from
put
my
my
side.
money where my mouth is. I don't mind paying more taxes if that'll bring everybody up, give everybody a certain sense of security. You see, I mean, you see hardworking people every day. They lose their jobs for no fault of theirs because maybe their job got shipped off to China or India. And I think our government needs to give them more of a security blanket. And the prevailing sense seems to be like, well, if you're not doing well, it's because you're not working hard. And that is so far from the truth, in my opinion.
Yeah, I mean, not to shift this whole thing sideways. As someone, and you've obviously worked very hard to get where you are. I work very hard, and I've always just kind of adapted with what the universe has given me, right? And so it's like when times get tough, I figure out a way to get tougher, right? Now,
Right.
I do think the one thing that when you look at in our society is there's kind of a divide sometimes, in my opinion, to people that just, it's like we all need to pitch in one way or another. And I do agree that people, unfortunate things happen to a lot of people, and they have no choice in it. And I do think that sometimes people have a unrealistic expectation with aging, right? Like, so sometimes I think for younger people, it seems easy. It's easy to perform physical labor. It's easy to sell when you have tons of energy and you can be wherever an industry needs you. But I do think that we need to value our families more, right? And I think that that's where things actually come and catch up to people. Even myself, like I got started really young. I mean, I had my daughter when I was 20 years old. She works in my company right now. She's 22. So it allows me to travel. I travel all over the country, but and then I'm 44. for other 44-year-olds that are raising kids right now, my life would be difficult
Yes.
for them, you know?
Yeah.
So, in the most important thing that's happened in my life is my daughter. So, I mean, Vic, or Vin, I'm sorry, I totally, I keep calling you Vic, by the way, because you're Vectra, and I see this video, and I instantly say that. So I have to explain this. I've done it twice, and I'm embarrassed I've done it. But anyhow, I do agree with you. I'm always kind of torn. I think that sometimes when you're a successful entrepreneur, people assume like you're what side of like the platform you're on, and I always say I'm very moderate. Like I totally believe in hard work, but I also believe that we're all here for a very short time, and we should all just try to look out for each other. So
Exactly
it's
that. And you made a point. You said you have the ability to rework yourself and adapt as things change. I'm like that myself. But we also have to recognize there's a lot of people that don't have that ability. So many people are struggling with depression and other health issues. Maybe they don't have the ability to adapt. And that's where society or the government really needs to be there to give them a hand. I see all these, you hear about these coal miners in Virginia, West Virginia, and they're losing their jobs. And you see Congress saying, oh, we got to keep these coal mines alive because it's going to kill those jobs. But coal as a whole has such a terrible impact on the environment, on the health of the miners. I think they need to give free training, help those miners identify what their strengths are and give them free training so that they can move to some career that's new, that's going to form the future of America and the world as a whole.
Yes. Now, the thing that I see with that though is people have to be willing to
Sure.
to make that change themselves.
Yeah.
So it's like that's what's difficult. Like so, even for myself. Okay, so the one thing for me is, I mean, I'm automating a space. I'm automating lawn mowing. Very
Uh,
simple. Nothing nearly as complex as what you're doing, right? But I can't tell you how many like hate messages I get from people that are unwilling to accept and adapt. And the one thing, and I mean, I might get myself into a little bit of hot water for saying this, but I'm going to say it because, well, it's my podcast, and I'll say it. If they don't like it, they can off. But you know, unfortunately, there's a lot of Americans right now that can't. They they don't realize the most valuable thing we have is actually what's right up here
exactly.
in well, right?
Yep.
So they for some reason, I don't know if it's in our school system, I don't know what it is, but they don't have an ability to form their own thought and actually accept change. They just want it to be the way that it is. This is
Yeah.
the way that it was. This is the way that it's been. This is the way it has to be. But we don't progress when we do that, right? So
Yeah.
one of the things I'm always trying to talk about is we can keep mowing grass with people forever. First of all, I don't even know why we have such a love affair with our lawns. I mean, I'm a landscape company. I make a lot of money off the love affair of lawns, right? But at the end of the day, the consumer is what keeps that cost value down, right? You
Yep.
said you worked at GL, okay? I I work for major corporations myself, and those corporations see lawn mowing as an expense that if they couldn't have it, they wouldn't. So they want that as low as possible, which means nobody's ever going to make more than $16 to $20 an hour in that space,
Correct.
which means they're going to live in poverty forever. But then when I am over here trying to automate that space, people are sending me hate messages saying that a guy like me is going to cripple our economy. And
Oh,
I'm saying absolutely not.
no,
This is,
no.
this is not the case. This would be like saying that the people that used to take the little plug when you dial a rotary phone and plug it in, that those people were going to support our economy, right? That is so far from the truth. So I think it's an uphill battle, right? Because the one thing I'll say is I believe in taking care of human beings, but I also don't like Now, this is where you and I are a little bit different, but this is great conversation because actually, after this podcast, you and I will probably be friends now. So, because intellectually, I think we can talk about this. I would rather help all the people in my friend circle than have more
Mhm.
government, right? And then try to inspire other leaders, business leaders, to help all of the people they touch. So there's not as much government. Because for me, looking at government, they have a way of bloating everything,
That is true.
overpaying themselves, and
Yeah,
then it never gets down to the people it's supposed to help anyways. So,
true.
so, we believe in the same thing. We just have different avenues to try to get there, but that's okay because it still means we just love people. So, it's all good, right?
Exactly. Exactly.
So, all right. So your family. So we're going to get off this because otherwise it's going to be a political podcast in a second. So, so, so are you, do you have brothers and sisters? Like how many people were in your family? You talked about mom,
So
dad,
I'm an
sister.
only child, um, but I'm very close to my cousins, probably because I was an only child. So I'm really close to my cousins. So, and I've been married to Sue for 30 years, going on 31 now. And we have two wonderful boys. The older one is 20, almost 26. The younger one is 22. The younger one is also following in kind of in my footsteps. Well, he's getting a head start in the entrepreneurial journey. He's working on a software platform that he expects universities will want to use. So that's where we are. And we love living in Raleigh, North Carolina. After spending 15 years in Michigan, we're tropical creatures. So
Yeah.
biologically, I'm a tropical creature, so we just love moving down here where it's temperate. We see snow maybe once in 2 or 3 years, and it's just absolutely wonderful.
Yeah. So, I'm from Illinois and actually I'm in Door County, Wisconsin right now as we speak. There's 2 feet of snow outside the window if you looked. And I don't know what it is when I was younger. Maybe you could comment on this. When I was younger, I loved the snow. I loved the smell of the snow. Everything about the snow I loved. And then I started a snow removal company. There's the hat I'm wearing right now. And and now snow just equals stress. People think, oh, it's white gold. You're making all this money, but I'm like, oh, I'm getting a lot of phone calls and there's a lot of liability. But the reality is, you're right. When I go to Florida and I go to these southern areas and I'm by the water, I'm like, why did people ever migrate north anyways? I never understand
I
it.
know.
I don't know if it's just I don't know if it's just as we get older, it's harder to deal with the cold. And when I was a kid, my legs would be raw, red. I'd come in after playing in the snow. I didn't care. Now when I walk outside for 2 minutes, I'm like, I'll wait till tomorrow when the sun comes out. So I get you, man. I totally understand. So first, honestly, with your son, that sounds like you inspired. Well, one of them. So you said the one son's making a software. What does the other son do? I
He's
might have
trying to
missed that.
still figure things out.
Okay, well that's okay. There's yeah. Awesome. Um, so then, do you have any mentors? I mean, who inspired you to get in engineering in everything that you're doing as an entrepreneur? That because we've all been
So
inspired by somebody.
when I was growing up in India, back in the early '80s, if you were good academically, your choices were pretty simple. You either became an engineer or you became a doctor. I hated biology, and my dad was an engineer by trade. He ran a mechanical engineering business, so it seemed like the natural thing to become a mechanical engineer.
Awesome. So, I mean, did you have any tough times in business you had to overcome? I mean, you said like myself, you've been able to adapt and change. You know, I mean, it sounds like everything's very successful right now, and everybody sees successful businesses as, oh yeah, it must have just been easy. I don't think they realize that there's some, at least for me, anyways, I've had some real head scratcher moments. So,
Oh,
uh,
I've been through all of that, and it's made me stronger. We've had a lot of ups and downs, and we had to put more and more money into the business to complete the development of our software and make it scalable. It took a lot more, and we had to bring on a whole bunch of investors to get here. It's not been easy, but somehow I find the strength when things are really tough. I get more focused, and we get more work done faster when things are tough.
so do you have any advice maybe for a guy like myself? Because like I'm kind of at that point right now. I've never needed an investor. Everything I've done, I've been able to do by myself. But since I want to go national, I do sometimes kick around investors. Like, was that hard for you the first time you took on investments? Does it ever get easier? Or do you have any advice for someone like myself? Because I'm very trepidatious about it, I have to tell you, you know?
What you're doing, Joe, robotic lawn mowing, that's huge. If you don't bring in investment and scale your company fast, you will have a whole bunch of other companies doing it. So my suggestion to you is bite the bullet as much as you don't like taking other people's money and having to listen to what they have to say. I'm telling you this because of what you're doing. That is huge. That's going to be game changing.
So I
I,
thank
I,
you
I
for that.
thought of back in when I lived in Michigan, I used to mow the lawn myself, and I used to think I got to come up with this robotic lawnmower. I always thought, but never had the time or the energy to come up with it. I'm glad to see you do it. It's going to the corporations are going to be your first market sector, because that's where the big money is. And then I think in 10 years, every home is going to be doing this with robotic
Yeah,
lawn.
well, I have to tell you, the houses are the harder ones because little Johnny leaves his baseball bat out and the robot gets stuck on it, right? Right. But you're right. The campuses, the commercial campuses, much easier to do because we have control. And the one thing that we do that's different is I buy the robot. So instead of selling it directly to the corporation, I buy them, put them out. So there's really no risk for them, but they get the reward of environmentally friendly daily robotic mowing. So, but yeah, I mean, the thing that's always hard for me is, like I said, um, you know, my business, I have a lot of family in my business. My brother is part owner of the business. I work. My daughter's in the business. My stepsons work in the business. So, you always just get nervous. You take on investors, and then they don't like somebody that's my family. So I mean, but I do agree with what you said, and I will after we get off the show. You're not the first person that's told me, like, if I don't scale it, I'm just going to make my competition is what's going to happen.
I think you have to focus on scaling all the issues of somebody not liking somebody else. You'll deal with it as they happen, or they don't happen, then you're in good shape.
And
But
then I'm going to get exactly.
yeah,
So we've spent close to an hour together here, and you know, I just want to see, like, where for me, I can't ever see myself retiring. I love what I do. Entrepreneurs love what we do, right? So, are you the type of person that has to start to think of your exit strategy, or are you in it until you can't be in it anymore?
well, since I've taken other people's money, there has to be an exit strategy. And I'm planning to take a lot more, several million in the next quarter from VCs. So there has to be an exit strategy, probably in 3 to 4 years, and that's already in place. We know how we're going to exit, but I don't see myself retiring like you. I just want to. I'll do something else after this. Maybe
Yeah,
it's something a little more passive, like commercial buildings or residential buildings, so I don't have to work 12 hours a day anymore. I had
yeah,
don't know what that is going to be yet.
yeah, yeah. I think the entrepreneurs in general, we're just problem solvers. So if we don't have a problem to solve, we're bored. I mean, that's what it comes down to for me, anyway. So then, this is the question I ask every person. This will be the last question I have for you. Then what do you want? What do you want to be remembered as? With what you did. What's your legacy?
Well, I want to be remembered as the guy that automated this tedious, mind-numbingly boring task of creating engineering drawings.
Awesome. Well, I think you've done it from what it sounds like to me. So
Yeah, we need now to
you
expand globally. So
yeah,
in 10 years, I don't see any engineers doing this work manually. It'll all be automated. We expect there
good.
will be few competitors in the meantime. Right now, there isn't anybody, but I have to assume that there will be.
Well, fantastic. I really enjoyed learning about what you do and how you've basically taken boring tasks that would probably be mind numbing to the majority of engineers out there and help them with some of that. I appreciate you taking the time. I hope you appreciated the time we spent together also.
Absolutely, absolutely pleasure talking to you, Joe.